All right, 0.6, sum of interior angles of a polygon. Students will be able to classify polygons and find the sum of the measures of the interior and exterior angles of polygons by completing a group activity. We're going to do that in class, kind of show you where this formula comes from. But I'm just going to show you the formula ahead of time. A couple of quick definitions. Polygon. This is a closed plane figure. Plane meaning like flat, with at least 3 sides that are segments, and their sides intersect at only their endpoints. So like intersect at only their endpoints. So for example, like that's not a polygon, because if you look, that's an endpoint, that's an endpoint, that's an endpoint, that's an endpoint. But see how those things intersect at those line segments intersect where it's not an endpoint, it's like in the center. So that's why. Okay, so that's a polygon. And they're line segments too. So like also important to note that like if you have something like this, maybe like part of a square but then like a circle, that's not a polygon because it's not straight, right? So if this is like curved at all, that's not a polygon. It has to be straight lines. Okay, so here's the basic formula that you're just going to want to pretty much memorize, and it's pretty simple. It's just that the sum of all the angles of any polygon equals 180, and then parentheses n minus 2, where n is simply the number of sides. So here's all your names for all your different polygons. I don't have 11 in there. You could Google it if you want. And if you don't know, if it goes past 12, you could, like if it was like a 13-sided figure, you just call it a 13gon. But these are the actual names in case you see them. You should know what an octagon is, or a nonagon, or a decagon. If you see those words, you need to know, oh, that's 10 sides. Okay, so that's for the interior, all right? That's the sum of the interior angles. But then if we were talking about the exterior, now the sum of the measures of the exterior angle of a polygon, one at each vertex, is 360. And the reason for that is kind of cool. I'd encourage you to just like draw any polygon. So I'm going to start with the triangle because it's simplest. And exterior angles are if you take each one of those and you just extend them. So like we have that one, and that one. And I want you to imagine this triangle getting smaller and smaller and smaller. In fact, maybe I could actually do this. What if I was to draw really tiny? Oh, my drawing's not so straight, but... And then we would zoom out. You can kind of see how all these angles eventually just make like a full, complete rotation. And that's why it's 360 degrees. Sorry, my handwriting's a little bit off. You could do it with a square, with a pentagon, with a hexagon. You can do it with any type of shape. You'll get the same result. See, so like, let's zoom in again, and let's draw like a hexagon. Okay. Okay, and here's my exterior angles. An exterior angle can only be one. Like you can't extend this and extend this because then they'd overlap. So we're just talking about the ones. Well, look, if I zoom out, you could kind of see how like those eventually would just make up a whole rotation, right? You could see how like if you just start adding all these angles up, it ends up being 360 degrees, a whole rotation. So that's why it's always 360. So no real fancy formula or anything there. It's just always 360 degrees. Okay, so a couple of basic questions here. It says, what's the sum of interior angles? So notice that it says interior. That's important. Of the polygon below. Well, how many sides does it have, right? It has 4 sides. So if we use this formula above, remember, S equals 180 times n minus 2. Well, we have 4 sides, so this would be 4 minus 2 times 180. Well, 4 minus 2 is 2, so 180 times 2, well, that's 360 degrees. And so a quadrilateral, that's a figure with 4 sides, is the only shape that has the same sum of interior as they do exterior, because everything has an exterior of 360. So I want you to use the same formula, try practice number 1, and then just check back with me when you're ready to check your work. Okay, so you should have counted that there was 5 sides, 1, 2, 3, 4, 5. I labeled them just to be sure. Plug that into your formula. 5 minus 2 is 3. 3 times 180 is 540. Boom. The angles all have to add up to 540. All right, we'll see some problems in the future how this is really useful, but it's just something you need to know. All right, see you guys on the next video.